Hey everyone, it's Miss Billman. This is Unit 5, Lesson 9, homework. During this lesson, we wrote situations, we wrote expressions, we also modeled. It's kind of fun, at least I think so. But then again, I'm a math kind of gal. So Miss Williams brought 7 boxes of M markers to school. At the end of the school day, 3 markers were missing. Whoa. That's like literally my worst nightmare, worst day ever. But for Miss Williams, we need to be able to write this expression in her honor. So I have 7 boxes of M markers. So I'm going to draw 7 boxes. They all have M markers. So maybe these markers have, or maybe these boxes have 10 markers in them, or maybe they have 1, maybe they have 100. Either way, they have M markers. And at the end of the school day, 3 were missing. Oof. So I'm going to write 7M, knowing that would be 7 times the number in there, minus 3. Remember that M could be any number. So in this case, they want us to evaluate it as if M equaled 12. So each box has 12 markers. So 7 times 12 minus 3. Well, 7 multiplied by 12 is 84 minus 3 gives me a total of 81. And that's how that one worked. Now we're going to apply the distributive property to write equivalent expressions. So between 6s and 42, the greatest common factor is 6. I pull the 6 out and I get s minus 7. Now I'm going to distribute. 9 to t, I get 9t plus 72, which is 9 times 8. Common factor here is p, and I get 5 plus 2. I distribute 3 to m, I get 3m minus m squared. M times n equals m squared. So now we need to tell if the expressions are equivalent or not. So 4a multiplied by 4b. Okay, well, I can do 4 times 4, and I get 16, and the a and b multiply together, and I get ab. So 2m plus 2 plus 3m, and 5m plus 2. Well, I combine like terms, and it works out to be 5m plus 2. And now we have 7, and I distribute it. So 4 plus 7x plus 7y. And if I look, I can always write for some odd reason a z, but I look and I'm missing. So no, that's not equivalent. And it says 4x squared, and I have 2x multiplied by 2x, and I get 4x squared. So yes, that is truly equivalent. Okay, this next section, they want us to simplify each expression and make sure we do the following. So do all of the computations we can. We are going to write each term with the coefficient in front, and we're going to combine like terms. So when I write the coefficient in front, remember it's a number, can't be a letter. It's like saying 6g and not g6. So we want to make sure we write the coefficient in front. So 2 squared plus x plus 3 squared. And that 2 squared plus x plus 3 squared plus x, 2 squared is 4, plus, I combine my x's because it's x plus x, and I get 2x plus 9, which is 3 squared. So I write 13 plus 2x. I'm combining like terms. Now I have 5a plus 5b plus 2a plus 3b. So I combine like terms, the a's, 7a plus 8b. And that's as far as I can go with that one. So 7a plus 8b. 4 multiplied by 5 plus 3 times 2x. And once I move my hand, you'll see plus 3. So 20 plus 6x plus 5x plus 3. I combine like terms, and I get 20 plus 3 is 23. And I combine 6x plus 5 and get 11x. So I'm going to final answer of 23 plus 11x. Now I got to distribute. The 5 to the 5m is 25m plus 2m plus 5 to the 6, 30m. I combine like terms, which is all of them. 25 and 30 is 55 plus 2 is 57m. Now I'm going to show you just how my mind kind of breaks down these expressions when I'm doing it. So when we have the sum of x plus b multiply by 6. I distribute the 6, and I get 6x plus 6b. I shouldn't have picked letters and numbers that looked exactly alike. So I look for their common factor. So what do they have in common? They have this 6 in common. So I've distributed, and now I'm going to take it away. And I know that's probably not the perfect mathematical term for it, but in my mind, that's what I call it. So I go from 6x plus 6b to 6 multiplied by x and b, x added to b. So it's the same thing that I started with. So let's look at things with numbers. So if I had 12 plus, let's say 36. So the greatest common factor they have is 12. I know 12 goes into 12, obviously, and 12 goes into 36. So I think of it as 12 times what? 1 plus 12 times 3. Remember, those equal 12 and 36. What do they have in common? 12. So 12 multiplied by the sum of 1 and 3. So when I multiply 12 times 4, I get 48. This would be the same answer if I added 12 and 36. This is how the distributive property kind of blows my mind. You could do so many things with it, and it really shows you how math can work in different ways. Remember, these are the samesies, and you totally got this.